Alright, hello everyone. My name is Vivek, and in this particular video, we are going to look into how we can deploy the application that we have already written in some of previous videos into Kubernetes. So we actually went ahead and wrote a REST API, very simple REST API in Go, and then containerized it, pushed the Docker image into Docker Hub. And in this particular video we are going to look into how we can use that image, or how we can deploy that particular application into Kubernetes cluster. So right now I have this Kubernetes cluster up and running, one node minikube setup Kubernetes cluster, and we are actually going to see what are all the resources that are involved when we try to deploy an application. So this application that we have written has two components, right? The REST API backend and the database. Okay, so let's just go ahead and try to understand the architecture. Okay, so let's say this is the application that I have, right? And this application is going to be deployed on a Kubernetes cluster, right? And this application is going to talk to MySQL database that we have. Okay, so let's say this is the database that is running on the same cluster. Okay, on the same Kubernetes cluster. So this is MySQL database. Okay, and this MySQL database would be queried by this particular application that we have already written and containerized. Okay, so as we have seen in the previous videos as well, if this application tries to connect to this particular database that is deployed on Kubernetes, this REST API application would need the connection details, right? For example, which particular host the MySQL database is running on, and what is the root password to connect, using which we can connect to the database. So these are all the details that this particular application needs, right? And so in this particular video we are going to look into what are all the resources, Kubernetes resources, that can be leveraged to achieve this configuration related things, right? So let's just go ahead. First of all, we would actually try to install MySQL. So let's just go ahead and try to talk about what are all the things, what are all the Kubernetes resources that we need to create in order to run MySQL. Okay, so MySQL is a database, so obviously we would need a volume, right? And in one of the previous videos we have discussed about these Kubernetes resources called PersistentVolume and PersistentVolumeClaim. Okay, so now if MySQL needs a persistent volume, there are a lot of ways, right? So for example, either we can create this persistent volume manually, right? Or what we can do is we can actually leverage another concept of storage classes in Kubernetes, and then we can dynamically provision this persistent volume, right? So MySQL is actually going to store the data in this persistent volume that we specify, right? Now to connect to this persistent volume, there is another resource that is used, and that resource is PersistentVolumeClaim. Okay, so we will have to create another resource named PersistentVolumeClaim, and this MySQL instance is going to query this volume using this PersistentVolumeClaim, right? So if I try to visualize this, this is how things are going to look like, right? Now again, there are a lot of ways to provision this volume that we have here, right? We can either provision this volume manually, or we can use some other ways, for example dynamic provisioning. When I say dynamic provisioning, I actually mean using storage classes to provision the volume. So if there is a valid storage class installed on your cluster, in your PersistentVolumeClaim you can specify that storage class, and a persistent volume would be created with the requested storage, right? So in other very simpler words, we can say that storage class is another Kubernetes resource that helps us with dynamic provisioning of the volumes in the Kubernetes cluster, right? So here we are saying we'll have to create two resources, persistent volume and persistent volume claim. So in our case, we are going to use, since we are running on Minikube, we already have this standard storage class installed, so we are going to use that storage class. So we will not have to manually provision the volume. We are just going to create the persistent volume claim, and in that persistent volume claim we will specify the storage class, and this volume would be created automatically. We are going to look into all these things in much more detail in just a bit. So once we have, and another thing that we need to run MySQL is we will have to specify MySQL root password, right? So what we can do is when we try to install MySQL, again there are several ways to install MySQL, and one of the ways is using manifest, MySQL deployment manifest, to run MySQL instances on your Kubernetes cluster, right? So in that manifest we can provide the MySQL root password as environment variable, right? But there is another resource that helps us to with these kinds of things, that is secret, right? So if there is something that should not be mentioned, that should not be there in the manifest files in plain text, in that case we can leverage secrets to store that information, right? Again, secrets are storage, we can say key value stores, where the value is base 64 encoded, right? So what we are going to do is we are going to create a secret, I would say, and this secret is going to have the root password for the MySQL instance, and this secret will be used as environment variable into this particular MySQL instance, right? Apart from that, once we have this particular setup done, we can go ahead and try to install or try to run REST API, right? So let's just go ahead and try to run MySQL on our cluster, and yeah, we are going to run it as deployment, not as stateful set, because we are going to run single instance of MySQL. And yeah, I mean, let's just go ahead and try to do that. So this is the repo that we have. In this repo I'm going to create a directory named manifest, and let's change into that directory. After that, if I go to Kubernetes docs, there is this example where they specify or where they tell us how to run MySQL. So I actually remember that. So this one, single instance MySQL. So this is the deployment manifest that we need to use, right? So let's just copy that into deployment.yaml, right? And we are going to leave everything as it is. Here we can see that the environment variable to this particular container is being provided by this particular field, right? And the value as of now is password, right? So what we can do is we will have to create a secret, and in that secret we would be providing the password. As you can see here, we are going to create this secret. In this secret we are going to specify the root password, and in the MySQL's manifest we are going to specify the environment using this secrets key, right? So let's just go ahead and try to, now that we have deployment.yaml, we will have to make some changes into that manifest after creating the secret, but let's just go ahead and try to create the secret. So kubectl create secret, and I'm going to create a secret of type generic. I think this needs config maps and secrets need another discussion. I may create another video about them, but this is the same command format that we have already discussed kubectl verb resource, and in the case of secrets, resource type. I am going to create this in namespace, let's say database, because we are going to install this entire thing in the database namespace. So this entire thing is going in the database namespace, and this REST API thing will be going into REST API namespace. So these are two namespaces that we are going to create. Okay, so -n database from literal and root password equals to, let's say, Vivek Singh, right? And if I press enter here, this particular secret would be created in the cluster, right? But we don't want to, we want to create the secret, but we also want to persist the manifest, so that in future we can get back to this manifest and see how did we actually create the secret, or if there are any changes that we want to make in that particular secret, we can also do that. So let's just try to create the manifest for this particular command that we have written. So secret.yaml. All right, so it seems we have not provided the name, so name is going to be MySQL-password, right? And if you look into secret.yaml, now we see that this secret, if I apply this particular manifest, this particular secret would be created in database namespace. Name would be MySQL-password, and as you can see, this is the key value pair that I was talking about, right? So root password is the key, and value is the value that we have provided in the command, right? And if I try to create this, we would be getting an error because the namespace is still not there. So let's just go ahead and try to create the namespace. Again, to create the namespace, we can just run kubectl create ns and then namespace, but let's generate the manifest and create the namespace using the manifest. Okay, so ns.yaml, and if I just apply ns.yaml data, we can see that namespace database has been created. Now let's just go ahead and create the secret. So secret is in the manifest secret.yaml, so create -f secret.yaml, right? And we don't need to specify namespace here because we have already specified namespace in the manifest itself, right? So here we have specified the namespace. So once secret is created, we can say here we are done with secret. Now let's just go ahead and create the persistent volume claim, right? So let's list the storage classes from the cluster, and then we are going to, so here we can see standard is the storage class name, and host path is going to be used to actually provision the volume, right? So let's just go ahead and create another manifest where we are going to store the PVC manifest. So if you look into this example once again, we can see that this is the manifest for persistent volume claim, right? So we are going to use the same manifest, but storage class is going to be standard that we have just seen, right? And we are requesting the storage of 20 gigs, and this is the name of the persistent volume claim, MySQL-pv-claim. Let's just save it, and let's just specify the namespace here. So namespace is going to be, persistent volume claims are namespace resources. So let's just go ahead and try to specify namespace as well. And if I just go ahead and create the PVC, as you can see, PVC has been created. And if I list all the PVC from database namespace, we can see that PVC has been bound to this particular volume. So again, if we go back to this particular diagram, we created PVC, right? But persistent volume was automatically created. And if we list the persistent volume, here is the volume that was just created, right? So now we can see we have secret, we have persistent volume claim, we have persistent volume. We can just go ahead and try to run the MySQL instance, right? So in this deployment.yaml, the root password is password now, but we want to get it from that secret that we have just created, right? So what we can do is we can specify, take the environment from, again I will have to check the documentation. I somewhat remember the syntax, but let's just look up to the documentation. Okay, so here is how we can read the secret and set as an environment variable. So value from and secret key reference. Value from secret key reference. Name of the secret is MySQL hyphen password, right? And key in that password, if we list the secret once again, the key is root password, right? So this simply means that set an environment variable named MySQL root password, and value for this environment variable is going to be key root password from the secret MySQL password, right? This is what we are trying to say here. Let's just save this, and then if we set the, let's say, namespace as well, right? And if you just apply this, I think we messed up the indentation when we pasted those things. Value from secret key ref, name would be MySQL hyphen password, and key is going to be root password, right? Let's just apply this once again. Here we go. So now that the deployment has been created, we can go ahead and have a look into the pods in database namespace, and we can see that MySQL is up and running, right? So yeah, I mean, if we look into this particular diagram, we have achieved this part, right? We have created the namespace, we have MySQL up and running. Now let's just go ahead and talk about this particular namespace that we are going to have. So in this particular namespace, we will have to specify some of the environment variables that this application expects to talk to the database, right? And those environment variables can be, let's just figure them out by going to our code repo. So if we look into our main file, these are all the environment variables that it expects, right? So db host, db password, and db name. Let's not provide API path as of now, but you would be able to understand what I'm trying to do here. So we will have to specify three variables, right? Three environment variables: db host, db password, and db name. Again, we don't want password directly in the manifest, so we are going to create a secret to specify the password, and to specify these two other variables, db host and db name, we are going to use this another resource named ConfigMap from Kubernetes, right? And sorry about the lighting, I think. Yeah, but anyway, you are not here to, I think, see me, so it would be fine. So if we, yeah, let's just go ahead and try to understand how we are going to use the environments into this particular deployment that we are going to create. So again, we are going to create a config map, right? This is going to be named as REST API config, and we are going to create another secret, right? And this secret is going to be same as MySQL secret, right? MySQL password. So this is MySQL hyphen password, right? So we can use the same manifest, but we will have to create the secret in different namespace, right? So this is database namespace, this is database namespace, and this is going to be REST API namespace. So, and we are going to use same secret, right? So yeah, let's just go ahead and try to generate the manifest for this particular deployment that we are going to create, right? So all right, we are inside manifests, and inside manifests we have all the manifests for MySQL. So let's just go ahead and create another directory, MySQL, right? And we are going to move everything.yaml to MySQL. Okay, and if we move into REST API, now we are going to create a deployment. I think we have discussed about this in some of the previous videos, in one of the previous videos. So create deployment, and name of this deployment is going to be REST API, and I'm going to run this image that we have already created and pushed into Docker Hub, right? So this is the image, and tag is 0.1.0, and this is going to be in namespace REST API, right? And we want to generate YAML for this, and if we look into this YAML, we can see that, let's just go ahead and try to add the environment variables that it expects, right? So here we can see the container, and this container expects some environment variables. Again, we can refer to the other manifest that we have already created, right? So this is the manifest that we have, and I think we can refer this, right? So this is how the environment is going to be mounted. So environment, but I think we should first go ahead and try to create the config map and the secret, right? So create config map. Name of the config map is going to be, let's say, REST API config map. This is going to be in namespace REST API, and again, config map is similar to secrets, but the value in the case of config map is not going to be encoded, right? So we are going to create this config map using the keys and values that the application requires. So let's say we are going to specify host equals to let's say abc localhost colon 8080, right? And what else do we need? From literal db name equals to library, right? And if I just go ahead and create this, we should not have created this. Anyway, REST API is not found. So let's just go ahead and try to create the namespace REST API. Again, we want to generate the YAML for this. So ns.yaml, and if I create this, we can see that REST API namespace is created. So if you try to relate everything from this diagram, now we have created the namespace. Now we are going to actually create the REST API config, right? So I'm running two commands actually. I'm running first one to actually generate the manifest, and second one to apply that manifest in order to actually create the resource. So this command doesn't actually create the resource, right? That is one thing that we can make sure of. So if I just go ahead and try to create the config map now, so I don't want to create the config map, I want to generate the manifest, and I'm going to put it in configmap.yaml, right? So if we see here, now we have configmap.yaml, db name is library, host is localhost colon 8080. Let's just go ahead and try to create that resource now. Okay, so now if we go back to the diagram again, we have created this config map, right? Let's just go ahead and try to create the secret in the REST API namespace now. So I'm going to copy that secret here, and let's just modify that to run on REST API namespace, or to be created on REST API namespace. Right, so now we have also created this secret, right? Now we are going to set the environment variables into this particular deployment using the values that are there in the config map and the secret. So okay, environment, and name of the environment is going to be what the application is expecting, right? So the application is expecting db host, right? So db host, and value is going to be from secret key or config key reference, I think, right? Config key ref, because db host will be read from the config map, not from the secret. So name is going to be name of the config map, and name of the config map is REST API CM, right? And key that we are looking for is host, right? Similarly, we want to add, or we want to set another environment variable, and that environment variable is going to be db underscore name, right? So db underscore name, again value is going to be from the config map key, and name of the config map is going to be REST API CM, and key from that config map we can see is db name, right? Yeah, so now that we have set to environment configs, we have to set another environment config that is db password, right? So let's just try to set db password as well. So name and db password, and the value is going to be from secret, right? So secret key reference, name is going to be name of the secret. So name of the secret is MySQL password, right? So MySQL password, and key from that secret is going to be root password, right? So yeah, I mean this looks good to me now. The another very important thing that we should discuss about is, let's say we have created deployment, right? In Kubernetes, when a particular pod tries to connect to or tries to communicate with another pod, in that case the concept of services comes into picture, right? So let's say we have this MySQL deployment, right? And REST API deployment would actually try to connect to the MySQL deployment. So in that case, we will have to create service resource, right? So let's just go ahead and try to create a service resource as well. So let's say this is how we are going to create the service resource. And if I make a request to this particular service resource, if I try, when we create a service resource, in service we actually specify what are all the pods I want to forward the traffic to, right? So in this particular case, let's say this MySQL instance, now it is running single replica of the pod, right? So let's say this is the pod that is being run by this MySQL deployment. So if I try to create a service to expose this particular deployment, in that case, this service, any request that comes to this particular service would be redirected to this particular pod, right? So this is how things are going to work, and we are going to. So yeah, I mean this is the service. In other words, we can say that if a pod wants to communicate to another pod, the ideal way is to create a service. So for example, REST API pod wants to connect to MySQL pod. In that case, we'll have to expose MySQL pod using a service. Now there are not a lot of 3-4 kinds of services that Kubernetes provides us, but when we for cluster level communications, we usually use cluster IP type of service. We can discuss about the services in detail, but in this particular video we are going to focus into the service type, that is cluster IP. And cluster IP is used when a pod tries to communicate with another pod inside the cluster, right? So yeah, I mean, let's just go ahead and try to create this service as well. Again, we can either copy the manifest of the service from this documentation, or we can create it by ourselves as well. So I'm going to change the directory to MySQL service.yaml, and if I just try to, let's just specify the namespace, and if I just apply this, a service would be created in this particular namespace, and in the backend there is another resource that gets created, endpoints. And if I try to list the endpoints from database namespace, we can see that MySQL endpoint has been created for this particular service, and it is going to forward the request to this particular path. And if we get all the pods from database namespace and we try to check the IP, we can see that our pod is running on this particular IP and MySQL listens on 3306, right? So any request to this particular service is going to be forwarded to this particular pod on port 3306, right? So yeah, I mean, this service has been created named MySQL. So if REST API wants to connect to MySQL, it will use the name of the service, right? And since REST API deployment is in separate namespace, MySQL service is in separate namespace, we will have to specify the namespace as well. So what would be the fully qualified name? Service name, that is MySQL dot namespace name, that is database. So MySQL dot database dot svc dot cluster dot local, right? So let's just go ahead and try to change the config map that we have created. So host is going to be MySQL dot database dot svc dot cluster dot local, right? So we don't actually need to specify this domain and subdomain, so we can get rid of those things. We just have to specify service name dot namespace, okay? And obviously on port 3306, right? So now that we have this thing ready, let's just go ahead and try to create this. So create -f configmap.yaml and in the namespace REST API. If the resource is already created, we want to update that, we can actually use apply instead of create. And if we try to get the config map now, this is the data that we have here, right? DB name is library, host is MySQL.database:3306. Okay, so now that we have everything set up, we can go ahead and try to create this deployment. Let's first make sure we have the secret also created. Config maps -n REST API. Do we have the secret as well? Okay, perfect. So let's just go ahead and try to create this REST API, right? So everything looks good to me. -n REST API. Okay, so it says config key reference is not a valid field, so there are chances that it is config map, or otherwise we can refer the documentation as well. Okay, so deployment has been created successfully. If we try to get all the pods from REST API namespace, this is still being created, right? Now let's assume that REST API, again we have set the environment variable using this config map and this secret, right? Now again, let's say we want to access this REST API, right, from somewhere else. We will have to again create a service, right, like we created service for MySQL. So let's assume that we want to access it from outside of the cluster. Let's go ahead and create a service, again let's say of type cluster IP, and we are going to name this REST API, and this is going to forward the request to this particular pod that we have. Okay, so all right, it is still being pulled, it seems. So again, if you want to look into why the status of this particular pod is in container creating, you can actually describe this particular pod, right? So, and then you can see that it is being pulled, but now it seems it has been started. So yeah, we can see that the pod has been started, right? Now the thing is, if the pod has been started, let's say I have to access this pod, right? Because this is an API where we have to access APIs slash v1 slash books, right? So to do that, let's just create the service first. Okay, so what we can do is kubectl get deployments -n REST API, right? And we want to expose this particular deployment using a service. So kubectl expose deployment -n REST API simply means the deployment that we are going to expose is in REST API namespace, and the name of that deployment is REST API, right? And we don't actually want to expose this, we want to specify the port to be 8080, and we want to create the manifest. So service.yaml. If we look into this, it simply means that if a request comes to this particular service on port 8080, the request is going to be redirected to this particular pod on port 8080. So this is what this service means. So let's just go ahead and try to create the service in the REST API namespace. Okay, so now if I get all the resources from REST API namespace, we have service. And again, in the real world scenarios, you would be creating ingresses. Again, that we have not discussed about ingresses yet, but maybe we would be discussing about them in future videos. So we would be using ingresses and load balancers to actually expose this to outside world. But just to show you in this particular example, I'm going to port forward my local host to this particular service. So let's say this is localhost, right? This is my host machine. So what I'm going to do is I'm going to say port forward localhost 8080 to this particular service, right? And as you can see, this service redirects the request to REST API. So let's just try to do that. I'm saying kubectl port forward in REST API namespace to the service named REST API on port 8080. Okay, so here we can see the details about this. Let's just open Postman, and parallelly we would be actually monitoring the logs of the pod just to make sure things are working as expected. So logs -n REST API, and this pod's logs, right? We don't have anything in the logs yet. So let's just go ahead and try to make get request, and you can see that unknown database library. It simply means that we were able to connect to the database, but we did not have anything in the database, right? So let's just go ahead and try to make a library database. So we know that the MySQL database is running in the, again, I'm sorry about the lighting. So in this particular namespace, you can see that MySQL instance is running, right? So let's just exec into that pod and try to insert some records. Okay, so get pods -n database, and if I exec into that, Okay, we are now inside that part. Now we'll have to get MySQL shell, right? So to do that, MySQL root hyphen password, and we have specified the password. Password of this MySQL instance is set from, if you remember, this particular field, right? And we are referring the secret MySQL password to the key root password. So this would be the value, okay? And if we try to decode that, because we know that this is base 64 encoded, right? So this is the password. So here we go. Now what we are going to do is we are going to insert some dummy records into the table, or let's just create the table. So create database library, and then use library, and then create the table books, right? So now we have created the table. Let's just go ahead and try to follow the logs of REST API deployment once again and make the request again. All right, so as you can see, we got 200, okay, but we did not get any response back, right? Because we don't have anything in the table. So let's just go ahead and try to insert something into the table. So we have this body already from the previous video that we created. If we just try to send it, we can see that we got 200. And now if I try to make the get request once again, we should be able to see the thing that we just pasted or posted, right? So yeah, I mean, this is how we can see we wrote an application from scratch, we containerized it, we deployed that application into Kubernetes, right? So yeah, I mean, again, if you have any question, you did not understand something, just maybe comment or let me know somehow. I would be happy to answer. uh, if we want to go through this architecture once again, we can do that. So let me quickly go ahead and try to summarize this, and maybe I would somewhere post this, let's say. So we are running MySQL as a deployment because, again, we in the previous videos we have discussed that to run pods we either create deployment or stateful set usually. So in this particular case we are creating deployment because we want to run single instance of MySQL. And we also, because MySQL needs a volume, to provision that volume we created a persistent volume claim, and MySQL needs an environment variable, and that environment variable, since it is a password, should be inside a secret, so we created a secret as well. Then we exposed that MySQL installation using a service, and so that the REST API deployment can access MySQL instance using this particular service. Similarly, REST API expects some environment variables, for example, the host where MySQL instance is running, the DB name that we want to connect to, and the password. So that's why we have created this ConfigMap and this secret. And again, to access this application, we have created this REST API service. If we just try to access the services from either REST API namespace or database namespace, we should be able to see a service of type cluster IP, right? And this is the service we are forwarding the request to when we say kubectl port forward. And this service, REST API service, if we explain this, kubectl, not explain, if we describe this, describe service, this simply means that, I think this is not very readable, so what I'm going to do is get service -n REST API, right? So it simply means that any request to REST API on port 8080 right, is going to be forwarded to this deployment. And how does this service figure out which particular deployment it should forward the request to? Using these selectors, right? So if we look into the pods from REST API namespace, this pod would have this particular label, right? And that's how service figures out which particular pod it should forward the request to. And the exact same thing happens in the case of MySQL as well. MySQL service has a selector field, and using that selector field, this service figures out which particular pod the request should be forwarded to, right? So yeah, I mean, this was pretty much it. I'm going to make a lot of other videos around Kubernetes, but I hope this clears a lot of things. And again, if you think this is going to be useful for your colleagues, classmates, maybe share it with them. Subscribe to the channel, and thank you so much. I'll see you in the next one.